Yes, hello, hi, welcome to your PDA. So myself, Srikanth Ganji. Today I am going to teach or I am going to solve one of the most important subject and theory questions will come from electrical measurements subject. So theory as well as the problems from energy meter. So which instrument is cheapest at disregarding the accuracy? So before going to the question solving, what is meant by measurement? So measurement is a comparison between the standard value and unknown value. Okay. So measurement means suppose I want to measure. So I want to measure in this circuit. I want to measure. Let us say I am applying a 5 volts here, and this is 1 ohm. And now what is the current which is flowing? Let us say it is 2 ohms now, 2.5 amperes. This 2.5 amperes, this 2.5 amperes is a theoretical value, or also called as a standard value, or also called as a known value. So theoretical value and or known value and also called as a standard value and also called as a true value. So true value. So the meters which are connected or the instruments which are connected to measure the voltage is called the voltmeter. The instruments which measures the current is called the ammeter. The instrument which measures the power is called the wattmeter. The instrument which measures the energy is called the energy meter. Okay. So now here we can place the ammeter here. This ammeter indicates, let us say this is called the 2.4 amperes or 49 amperes. This is called the measured value. So you can know the error value that should be is equal to measured value minus true value by true value. So that we can say that it is a static error. Which instrument is the cheapest? Disregarding the accuracy. So moving coil or moving iron or electrodynamometer type and rectifier. Out of all these four, so which one is the cheapest? See, is not asking about the accuracy, and PMMC will measure the DC here. PMMC will measure the DC, and moving iron will measure the AC, and electrodynamometer, yes, AC or DC, and here also AC or DC, and the rectifier type of instrument which is more accurate, yes or no? So which measures the DC? Okay. So for this type of answers, the electrodynamometer type of instrument, so which is cheap. So a 1 milliampere ammeter has a resistance of 100 ohms. It is to be converted to a 1 ampere ammeter. The value of the shunt resistance is asking. The value of shunt resistance. Think what are the formulas are there. So which formula is important? So think. So first of all, I will take 1 ammeter. So meter here. So this is called the meter resistance is Rm, and the meter current is 1 milliampere. Okay. Now it is extended to 1 ampere. Now it extended to 1 ampere. Obviously there is no other option. So in series the current is same. You can connect a shunt resistance here. Shunt resistance should be is equal to RSH. The shunt resistance is equal to RSH now. Now direct formula where RSH is equal to Rm by M minus 1, where M is equal to I by Im. So meter constant where M is equal to I by Im, where I is equal to 1 ampere by 1 milliampere, 1 into 10 to the power minus 3. So that should be is equal to 1000. And RSH is equal to RM meter resistance is called the, how much meter resistance is called the 100 ohms is given 100 by, yes, 1000 minus 1. So 1000 minus 1, 100 by 999. So 100 by 999. So obviously it is A option, 0.001. So 0.001. So 0.001 is a correct answer. And the pointer of indicating instrument is generally made of. This is appeared in Transco 2012. Okay, and so the windings are made up of copper, and silver is costly and soft steel. So these are having a weight. It has a weight. So this also has a weight. So this also has a weight. But aluminum, so aluminum, it is made up of aluminum. Why? Because it has a light weight. If it consisting of a weight, then definitely frictional error, that error will be occurs. Suppose I want to measure the 5 amperes, but the meter shows only 2.5 amperes. 50% it produces the error. It will produces 50% of the error. So that's why the pointer is made up of aluminum. The pointer is made up of aluminum. Okay, sir, 2 question answer B. 2 question answer. Okay. Right. 1000 divided by 99. Yes, 0.0. So 0.101, because I don't have. So okay, 0.101 is the correct. Right. So this is correct. So electrostatic instruments are used. Electrostatic instruments are used now. Okay. Right. The electrostatic instruments are used as dash. See, if you go for the electrostatic instruments are used as, so it cannot be used as a meter. So we can use voltmeters only, electrostatic voltmeters. Why? Because see, there are two plates are there. One plate is connected to with the help of a spring here, and this is called the fixed plate. Otherwise, fixed plate or moving plate. This is called the moving plate. And this one is called the fixed plate. If the charges are formed here, on the electrostatic, either AC or DC, you see polarities are formed here. So because of attracting force, this one, because of attracting force, so the one plate is moves towards here, and this charge formation is directly proportional to voltage. So it will measure the voltage. So voltmeter, it acts as a voltmeter. So 25 kilovolts, if you want to measure the 25 kilovolts also, you can use the electrostatic voltmeters. Okay, so generally it is famous now. So a 50 volts range voltmeter has a sensitivity of 20 kiloohms per volt. The total resistance of the voltmeter, Just solve it. See, sensitivity. So 1 by sensitivity, that should be is equal to current. 1 by sensitivity, that should be is equal to current. So okay. So what is the current value is equal to 1 by 20 kilo ohm per volt. So otherwise you can directly multiply. So directly multiply these two. 20 kilo ohms into 50 volts per volt into 50. So that should be is equal to 10. 20 kilo ohms into 50. How much it will use? 2.5 or 1 mega ohm. 1 mega ohm. So 1 mega ohm is the correct answer. Yes, D is correct answer. You already answered this. Okay. Transformers used in conjunction with measuring instruments for measurement of high voltage and high currents are called. So if you want to measure the high voltage, if you want to measure the high current, so shall I say the transformers meter and power transform, pulse transformers, instrument transformers. So CT and PT. CT is the current transformer. SD. So APS PDCL, you can see easy. If the connections of a moving iron voltmeter connected in a circuit are interchanged. If the connections of a moving iron voltmeter connected in a circuit are interchanged, then the voltmeter, what it will shows, will not give any deflection, will deflect in opposite direction, will be remaining effect, will burn out. Tell me. Yes. Yes, B. Is it B? Check. Moving iron voltmeter. So moving iron is measured AC or not. It is specifically used AC during positive of cycle as well as the negative of cycle. We are having a positive of cycle and negative of cycle. Is there any, if I am connecting a moving iron, is there any change? Only unidirectional, yes or no? The pointer moves, yes or no? So it will not, so reading will not be affected. Suppose if it is DC means the pointer will move some opposite direction. And also, if you observe that, torque is direct, deflecting torque is equal to half I square dl by d theta. Even current direction is reversed, I minus I whole square. Minus I whole square will become positive. Minus I whole square will become positive. Which of the following instruments is exclusively used for measuring radio frequency currents? Radio frequency. Tell me. Radio frequency. Yes, moving iron instrument which is used, if the frequency is increases, then obviously if a frequency is increases, what will happen? Hysteresis frequency error will be increases. Thermo PMMC frequency is zero. This is used only for DC. Frequency is zero. Electrode dynamometer type of instruments is also used for the 50 Hz. Why? Because the wattmeter is electrodynamometer type wattmeter. So thermocouple instruments which are used for the radio frequency instruments, thermocouple instruments. So the option B is correct. Now the ratio error in the current transformer is attributed to. So what is the ratio error formula? Think. Respond. Yes. So ratio error formula where so actual ratio plus IC cos delta plus IM sin delta by I naught. IC cos delta plus IM sin delta by I naught. So this magnetizing component of the current is more. So A option is correct. Magnetizing component of the no load current. Just now I told the difference between the indicator value and true value. Okay. The difference between the indicated value and true value of the quantity is known as Gauss error or absolute error or dynamic error, relative error. It is absolute error. It is an absolute error. So here Gauss error is different, which is related to what? true value. So difference is, which is related to true value, but dynamic error, it's a different. Relative error, so errors by something, but absolute error, it is a difference between the indicated value and true value. He is asking the difference. He is asking the difference. An instrument gives the maximum deflection for any amount of quantity passed through it. Which one of the following pairs is present? Tell me, which one of the A, deflecting and controlling torque. Okay. Yes, next. Others. C. Yes, excellent. C is the correct answer. C is the correct answer. Why? Because see, whatever the amount of current you can pass, here through meter, it will goes to, yes, it will goes to. So whatever the amount of current passes through meter, ammeter, let us say this is called the ammeter. Okay, now it will goes to final position. Either is 1 ampere, 2 ampere, 3 ampere, okay, whatever it may be. What is that meaning? Deflecting torque is deflecting. What is meant by deflecting torque? The force required to move the pointer from its initial position is called the deflecting torque. The force required to move the pointer from its initial position is called the deflecting torque. So it will comes like this. But if the controlling torque is absent, yes, obviously if a controlling torque is absent, then it will goes to final position, right? So additionally it is given. So after that it will not make the oscillations. Okay, damping torque is given. So C option is correct. C option is correct. Okay, a moving coil galvanometer is made into a DC ammeter. Moving coil galvanometer is made into a DC ammeter by connecting. So just now we solved two problems. So what is the answer for this one? C. Huh? Is it C? Is telling clearly DC ammeter. DC means how pure inductance is there. Moving coil, just now we have seen that this is called the RM. So meter current, we have seen that 1 milliampere. We are going for the 1 ampere. We are connecting shunt resistance with a low value of shunt resistance, so that so this should be is equal to 99 milliamperes, or no 90, not 999 milliamperes. So low resistance across the meter. A is the correct answer. Low resistance across the meter. So a moving coil instrument has a resistance of 0.6 ohms and a full scale deflection current of 0.1 amperes. To convert it to an ammeter of 0 to 15 amperes, 0 to 15 amperes range, the resistance of the shunt should be, A. Check. Yes. Right. So solve it. What is the answer for this one? So D, okay. As the resistance, meter resistance is directly I'm writing my meter resistance is 0.6 ohms, and full scale deflection meter current is 0.1 ampere, at 0 to 15 amperes, then the current is 15 amperes. So find the multiplication factor where M is equal to I by Im. So M is equal to I by Im. So 15 by 0.1. So that should be is equal to 150. 150 where RSH is equal to Rm by M minus 1. M minus 1. So what is the meter resistance is 0.6. M is how much? 150. Yes, 150 minus 1. So 0.6 by 149. So approximately, so 150 means 4.004. Okay, right? 0.0. All of you got the same answer. 0.004. Now, it's very important. The effect of stray magnetic fields on the actuating torque of portable instruments is maximum when the operating field of the instrument and the stray fields both are. So tell me, which is parallel, ma? It's a direct question. It is. So, so which is a parallel? Parallel. So either it is 0 degrees or 180 degrees. Either 0 degrees or 180 degrees. Adds or subtracts. So the effect of stray magnetic fields on the actuating torque of portable instrument is maximum. Okay. 0 degrees is added and 180 degrees is subtracted. So anti-parallel, anti-parallel. So 0 degrees means parallel. So external magnetic field are also called as a stray magnetic fields. Stray magnetic fields means suppose if a meter is kept when you are doing one particular experiment, and if externally you can keep the magnet. Suppose if the meter is showing 2 amperes, from your point of view it is showing 2 amperes. Here you can keep the magnet, and this magnet and internally meter is having a magnet, so both are attracted. It will so moves to S, either 4 amperes or 6 amperes. It shows the wrong reading. That is called stray magnetic field error. That is called stray magnetic field error. So that's why whenever if you may observe that LPF wattmeters, low power factor wattmeters in your laboratory, you may observe that that should be in wooden box, because it is electrodynamometer type of wattmeter, low power factor wattmeter. The stray magnetic field error is more in that meter. So that's why that is kept at a wooden box. Right, okay. So once again, it's a transco 2012 questions. And 12 question, an ammeter has a current range of 0 to 5 amperes and its internal resistance of 0.2 ohms. In order to change the resistance range to 0 to 25, we need to add a resistance. So how many questions? See, how many questions are came from the extension of PMMC used as an ammeter. Extension of PMMC used as an ammeter. Okay. See, so all are previous questions only. It will build your confidence. If you solve the more number of problems, okay, it will build your confidence, right? So within a less time, you should just by attending the so classes. So we are going to solve problems in the live sessions, and if you join in Uberpedia, so there is a Zoom session is live session is going in the Zoom. Okay, but it is not a public, so you have to pay something. So that is a less cost only. I think it is 3K, right? So A already answered. Someone is giving the answer. An ammeter has a current range of 0 to 5 amperes. Yes, meter current is 5 amperes. Simply No need of going for the normal procedure. Normal procedure is lengthy. So I is equal to 25 amperes, and where M is equal to I by IM. I by IM should be equal to 25 by 5. So M value multiplication factor is 5. Then RSH is equal to Rm by M minus 1. So what is the meter resistance is 0.2. That's 0.2 by 5. 0.04 na? 0.04. Someone is got D option. Why? It's D option. C option is correct now. 0.04 is correct now. Okay. In 0.0 ohms in parallel with the meter. Yes, it's an excellent question. And this question is a gate question. This question is called the gate question. The gate 1 mark question from the measurement subject. So those questions, Transco or Genco or what are the EPDCL or what are the questions? Some of the questions are from IES questions, some of the questions from gate 1 mark questions. Okay. Check. Yes, already answered. Sir, 0.2 by 4. Right. That's why you should tell me 0.2 by 4 is called the 0.05. That's why I'm asking, is there any mistake? Is there 0.05? So this is 0.05. Okay. Right. So 5 minus 1 is called the 4. So that you have to substitute. See here it is called the 0 PMMC instrument is -8. Okay, so this sine component is called the AC component, and this is called the DC component. So it will indicates -8 amperes. Okay, so -8 means either C or D. But if you check, if this current is given to the moving iron instrument, if this current is given to the moving iron instrument, so under root of so DC voltage or DC current square, so V I max by root 2 whole square, I max by root 2 whole square, that should be is equal to 10 amperes. 10 amperes. And true RMS meter is also 10 amperes, and moving iron instrument is also 10 amperes. The option C is correct. The option C is correct. This is a very important question, ma. This question is very important. Out of all the meters, 1 meter which is not having controlling torque, 1 meter which is not having controlling torque. B, yes, excellent. The B is electrostatic voltmeter. Yes, controlling torque is there. When the plate is moving, yes or no, I am connecting a one spring, controlling torque is there by the spring. And wattmeter is also having a electrodynamometer type wattmeter, spring. Dynamometer type ammeter is also having a spring. So power factor meter has no controlling torque. Power factor has no controlling torque. So next, the instrument which good accuracy for measurement of AC quantities. So overall, all these B, check. Is it a B? Check. AC quantities. He's asking only AC. Huh? How is B? AC quantities. Yeah. Most of them are answered B. Noma, you forgot this induction type. Induction type. You forgot that induction type, right? Induction type is having a good accuracy when you want to measure the AC quantities. Okay. So what are the errors are there in a moving error instrument? Hysteresis error, frequency error, stray magnetic field error, temperature error. Okay, frictional error is induction type. Induction type is the correct answer. So pick the odd one out. Pick the odd one out. Let's check it. So yeah, tell me. Odd one out. Moving errand instrument. Yes, moving errand instrument, moving coil instrument, dynamometer type of what instruments. So which are measures, okay, and which are having is it B? Moving, yeah. So this will measures DC and this will measures AC. Okay, dynamometer AC or DC? Here it is AC or DC. Which one is the correct answer? This is the AP SPDCL 2014. Two options are there. Out of two options, you have to eliminate one. Yes. Yes. All are these three are indicating type of instruments. These three are indicating type of instruments. But here it is a recording type of instruments. Recording. The continuously the disk is rotating and it is recorded. The value is recorded. So D option is correct. The D option is correct. Now 90 degrees the response of the meter in square law. Assuming spring control for a current deflection. AC and DC, yeah, AC and DC is MI. MI, as I told, MI is AC and DC. And also dynamometer type is also AC and DC. Okay, so you can do it. So try to solve this. So ISRO 2014 exam. ISRO 2014 exam. Yes. Direct answer. Tell me. Square law response. Theta is directly proportional to I square. Theta is directly proportional to I square. Square law response is given. TD is directly proportional to I square. Once TD is equal to TC, the equilibrium point is obtained. Once TD is equal to TC, as a deflecting torque is produced by 5 effects. One is called the magnetic effect. Okay, so Hall effect, electrostatic effect, thermal effect, chemical effect. So those are all there. But after that, controlling torque is produced by two effects. One is spring control and another one is called the gravity control. So we use spring control for PMMC instrument or MI instruments so that it is accurate. If you use a gravity control, proper leveling is required. Okay. If you go for the derivation of a deflecting torque for a MC instrument is BINA, BINA. But if you go for the MI instrument, the TD is directly proportional to I square. Or TD is equal to TC, equilibrium point is obtained, but the pointer will make some oscillations. In order to reduce the oscillations, we require one more torque, that is called the damping torque. So that is a background story. So theta 2 by theta 1, theta 2 by theta 1 is equal to I2 by I1 whole square. So I2 by I1 whole square. C is excellent, is correct answer. So this is 45 degrees by 90 degrees is equal to I2 by 1 whole square, and this is I2, yes, yes, 1 by 2, 1 by 2. So 1 by root 2, so 1 by root 2 value is 0.707, 0.707. A 50 Hz bar primary CT has secondary with 500 tons. The secondary supplies 5 amperes, as I told, 5 amperes. Purely resistance 1 ohm. The phase angle with the primary and secondary is asked. Phase angle between the primary and secondary is asking. Okay, so it is related to CT question. So try to solve it. So I will come. Yes, what is the answer for this one? So someone is answered C. No, not yet answered. Yeah. So you should go for the formula. If you use the formula, then you will get 85.4 degrees. Okay, where theta is equal to 180 degrees by n pi. So 85.4 degrees. Direct formula, based on that formula. So he may just now is solved this. This question is repeated now. So 12. This one is called the 12. Typing mistake. It's a 12. So Hyderabad Metropolitan Water Supply System 0.707. So dielectric loss in a capacitor is best measured by. So think and tell me. Think. So B, shearing, right, super. So this is for used for the measurement of frequency, and this is used for the measurement of capacitance, dielectric loss, and this is 5-point bridge. This is called the 5-point bridge. Okay, and also measurement of inductance. This is called the mutual inductance. We can measure the mutual inductance. Okay, Heaviside Campbell's bridge. With the help of this, we can measure the mutual inductance. Right? Obviously, dielectric loss. So already I given a dielectric loss is measured with the help of a sharing bridge. B option is correct. Sharing bridge. Yes. Next. High voltage sharing bridge is used for the measurement of. High voltage sharing bridge is used for the measurement of. So, resistance and inductance, frequency of AC source, loss angle of capacitor. Okay, so check. Right. Normal sharing bridge, which is used for the measurement of quality factor Q, where the Q value is greater than 10. Q value is greater than 10, we can use sharing bridge. And resistance is measured by using Kelvin's double bridge, okay, Wheatstone bridge, voltmeter ammeter method, and so many methods are there. And inductance means you can Maxwell's inductance bridge, Maxwell's inductance capacitance bridge, Owen's bridge, and just now we have seen that Anderson bridge, and the frequency of AC source Wien's bridge we can use, and the quality of coil is measured normal sharing bridge. So there is a special, okay, loss angle of the capacitor. Loss angle of the capacitor, C, correct, C is correct. Okay, so just now I told Kelvin's double bridge is used to measure the resistance. Resistance are three types. One is called the measurement of low value of resistance, less than 1 ohm, less than 1 ohm. So low resistance is less than 1 ohm, and medium resistance is 1 ohm to 100 kilo ohms, and high resistance is greater than 100 kilo ohms, and low resistance is Kelvin's bridge, Kelvin's double bridge, Kelvin's double bridge. Okay, Kelvin's double bridge. Okay, and also Kelvin's double bridge, which is used to measure the resistance of the transformer, primary winding as well as the secondary winding. So very small value of resistance. We know that transformer winding resistance, and medium resistance. So medium resistance means you have a voltmeter ammeter method, ammeter voltmeter method, and Wheatstone bridge. This is very important. Out of these, Wheatstone bridge is very much important. High resistance method. So this is mega ohm bridge. Okay, loss of charge method, and also called as the Megger. So Megger, we can use Megger. In that Megger also we are using the permanent magnet. This is an important question mark. Important question. So if you need, try to note it down. This is very much important. So now tell me, measurement of low resistance is correct answer. C is the correct answer. C is the correct answer. Okay. Next. Which of the following is used to measure the frequency? Just now I told. Direct answer. Tell me. See, you should remember. You should study in a proper way. You should study in a proper way that. So if frequency is there, if there are 4 options are displayed here. So if you read theory now, it will take 1 year time. Not only measurements, machines. You have machines. Yes, power systems and network theory and measurements. Okay, so UW, utilization of electrical energy and control systems, all the syllabus. Take this type of practice session, and there are 4 options are displayed here. Yes, Wien's bridge is correct. There are 4 options are displayed here. Why not this? Why not? Why not? Why this one? So like that you can prepare. So it will reduces your time and improves the quality. So no need to mug up the question and answer at the stage of okay, at the level of the stage. If you mug up, you didn't remember anything. Okay, now Which of the following may be used for frequency measurement? Again, the same question. Again, the same question, mean bridge. So, high resistance, which is having a three terminals, that is called the God terminals. So, generally, Hayes bridge, both L and C measurement, no. Hayes bridge is used for the measurement of Q and inductance. Is maybe the capacitor is there, but it is used to measure the inductance only. Okay, Owen's bridge is L in terms of C. C is a known value. Okay, Hayes bridge is no. Okay. See, quality factor, when we are calculating the quality factor, both L and C elements are there, then only we can calculate the quality factor. For the less than 10 of the quality factor, Maxwell's inductance capacitance bridge is used. Where the quality factor is greater than 10, we are using a Hayes bridge. So, bypass the leakage current. Yes. To avoid the leakage current. A bridge circuit works at a frequency of 2 kHz. Okay. So, anybody is observed in the laboratory, anybody is observed. For a PMMC instrument, we are using a galvanometer. PMMC instrument, we are using a galvanometer. For AC measurement or our 50 Hz frequency, we can use the headphones. And greater than that of 50 Hz or high frequency, we can use vibrational galvanometers. And also tunable amplifiers. Yes, someone is already answered. Vibration galvanometers and tunable amplifiers. Okay. Just wait. I will see the question completely and I will display here. So question is correct. This is 3 ohms, 11 ohms, 2 ohms, 4 ohms, 15 volts. The VPQ is 2 volts, VRS is 15 volts. The bridge is balanced or not balanced. You can check it. Check for this circuit. Read the question. So read. See, which is not true. This condition, this you have to read, which is not true. Which is not true is asking. Okay. This is P and this is R. So VRS is 15, correct. VRS is 15 is correct. And the bridge is balanced. 3 into 4 is 12. 11 into 2, 22. Not balanced. Okay. It is not balanced. That means your answer is C. Your answer is C. See here, in AP SPDCL 2019 also, the bridge is used to measure the frequency. See how many questions, how many. Yeah. Frequency. Just now we discussed Wien bridge. Wien bridge is used to measure the frequency. So which bridge is used best suited for use in harmonic distortion analyzer? Harmonic distortion analyzer. A. A is heavy side. Check. Okay. Multiple responses. See here, this is measured for the mutual inductance, measurement of mutual inductance. And this is the resistance, low value of resistance. And this is measured only frequency mark. But here harmonic distortion analyzer is sharing bridge. Okay, so sharing bridge. So what are the points are there in sharing bridge? Tell me. It is used to measure the capacitance. It is used to measure the dielectric loss. And also there's a tan delta loss dissipation factor. And also which bridge is used for the harmonic distortion. So D is correct answer. Yes, D is correct answer. Okay. In a PMMC instrument, the damping is provided. PMMC instrument, which type of damping is used? Okay, already answered. Okay, you are thorough with the subject, the measurement subject. Excellent. Yes, all of you saying only one answer. C is the answer. That's why it is very strong. Eddy current damping. Eddy current damping. So eddy current damping is a correct answer. Eddy current damping. In the diode rectifier, this you have to calculate. Rectifier. So rectifier which converts AC to DC. So try to calculate this one. See, no. Try. See, 2 amperes. Okay, check it. So I will check the question also. Yes. See, so question is not visible here. Right, current source or source R is equal to 1 ohm. Okay, nothing is a problem. So first of all, input is given here. Input is given. You know that diode rectifier. Diode rectifier is like this. So for understanding purpose, as I am giving like this, I am drawing like this. So here it is a phase. The neutral is connected to another leg, and this is my circuit resistance. When a DC AC is given to you, your output is like this. What is your output? Your output is okay, pulsating DC. V0 is pulsating DC. Obviously, I0 is also pulsating DC. So, and here he is connecting the ammeter. Here he is connecting the ammeter. So, ammeter is connected in series with the load. So, it will reach the average value. PMMC will gives the average value. PMMC will gives the average value. So what is the I average? Tell me for this waveform, I average is equal to 2Im by pi. I average is equal to 2Im by pi. So Vmax is 200 and similarly Imax is equal to Vmax by R. So 200 by 1. 200 by 1. So this answer is there or not? Okay. 2Im by pi. Okay. So something data is missing here. 400 by 5. 400 by pi. Okay. Something data is missing in this question. We will see in the next session data is missing. So that is not visible. So ammeter A, yes, 200 sin omega t. So Vm by pi. So this formula is correct, ma. So analysis is only one thing. Here ammeter will reach the PMMC and ammeter will reach the average value. So average value of the full wave rectifier is 2Im by pi. Full wave rectifier is 2Im by pi. Maybe it is 10, maybe it is 100. You can take it as 100 now. So 100 means obviously 2 into Im. What is the Im value is 2 here, 2 by pi. So let's take it is 4 by 5. So like that. Okay, maybe. So here the data is missing now. Now, okay. Still now we discuss. See, AP Transco 2017 is asking extension of PMMC, PMMC used as voltmeter. Try to solve this one. Extension of PMMC used as voltmeter. Okay. C. Is it C? Check. So meter resistance is 3 ohms. So meter resistance is 3 ohms. And to measure the voltage up to 300 volts, the external resistance is required. 30 milliamperes. The current is 30 milliamperes is given. Now, external resistance you have to convert. So now, what is the voltmeter range? This voltmeter range is 300 volts. So direct formula RSC is equal to Rm into M minus 1. Okay, so otherwise the current is same. Vm by Rm is equal to S VC by RSC. Like that you can go. So this voltage plus this voltage is equal to total voltage. And if you want to get the current is constant now, then RSC is equal to, you will get one factor. That is the theoretical. So Rm is equal to 3, where M is equal to V by Vm. But in the problem is not given directly Vm. So where Vm is equal to 30 milli into 3. So 90 into 10 to the power of 3. 9 into 10 to the power of minus 2. So 0.09. Whether it is correct or not, tell me, ma. 0.09. So V is how much? 300. This is 0.09. 0.09. So V by Vm 0.09, correct. 0.09. So that you have to substitute here. So this is 300 into 10 square by 9. So 3 3 ja 100 into 10 square by 3. So that you would substitute here 10 power 4 by 3 minus 1. What is the answer? Tell me, I don't have a calc. Tell me. What is the answer for this one? Okay. See, in some of the questions you may have calc or not. Okay. You may have a calc or not. But if you solve the more previous year's IES papers and previous GENCO papers or TRANSCO papers and previous papers, direct answer, ma'am. Because in the examination, he may not give. So, calc is not allowed. First of all, calc is not allowed. But by practicing only we can remember. By practicing only we can remember that the answer is C. 997. 997. So, same ammeter story. Ammeter, you have to find, you have to solve it. You have to solve it. B. Okay, 997. Okay, ma. Calculation, check once using your mobile or calc. Okay, right. 997 or 997. You will check it. Okay. So here, so meter current is shortcut. You can use 100 microamperes, and the coil resistance is Rm is equal to 1 kilo ohm. 1 kilo ohm. To convert the instrument into an ammeter, so RSH is equal to Rm by M minus 1. M you have to calculate. So 100 milliamperes. 100 milliamperes by 100 micro. This should be is equal to 1000. Okay. So 1000 by 1000 minus 1. Approximately equal to 1. Huh? B. All of you getting B. All of you getting B. Yes, right? Okay. The pointer of a moving coil ammeter deflects from 0 and comes to rest at 2 amperes marking. In the steady state, deflected position is which one is correct? Which one is correct? C. See, just now I told na which torque is 0. Rest at 2 amperes marking. So maximum value is 2 amperes ma. It is directly comes to final position. It directly comes to final position. Which torque is 0? Yeah. How ma? If we see to push the pointer, deflecting torque is required. So the force required to move the pointer. So with that force, it will go final steady state. But to oppose this deflecting torque, controlling torque is required. But what he is saying, so it is going marking is 2 amperes. It will go to final position. Okay, final position. What happened to the controlling torque? The controlling torque is 0. The controlling torque is 0. TD is equal to TC kada, sir, a steady state. But what he is saying ma comes to rest at 2 amperes. Rest at 2 amperes. And even that is there at 2 amperes only. The maximum point is 2 amperes and that is there at 2 amperes. Steady state, so see deflecting point, so it will comes to like this. But if a damping torque is not there, it will make, okay. He is not talking about the damping torque here. So it is directly deflected. Okay. So think logically. Previous question also, you may observe that. So TD, it will comes to yes final position. So what happened? TC is 0. TC is 0. AP Genco 2017 question, latest question. So 7 years back. Okay. You have to try to solve this one. Try to solve this one. About B A. Check once. Direct substitution. It's a direct substitution only. Okay. So this is area 200 millimeter square. Flux density Bmax is equal to 2 milliweber per meter square. So you can write it as 2 millitesla. Spring constant Kc is equal to 0.16 into 10 to the power of minus 6 Newton meter per radian. See, if you believe or not, in so many competitive examinations, is asking the units of spring constant. Units of spring constant. Most of them they didn't remember. Okay. So if you write once and twice, then you can easily remember this units, Newton meter per radian, spring constant Kc. Okay. So if a deflection of S theta is equal to 90 degrees to be provided, S theta is 90 degrees, when a current of 5 milliamperes, yes, 5 milliamperes, the number of turns is asking, number of TD is equal to TC, equilibrium point is obtained. Once you think, wow, see, steady state means is a final state. Whether, okay, if you switch on the fan, it will take some time to reach a fixed speed. If you switch off the fan, then it will take some time to comes to rest position in the zero position. Okay, right? So rest at final position is asking, right? TD is equal to TC. TD is equal to Bina. Okay, సీతయ్య ఎవడు మాట ఏనాడు కదా, సో అలా గుర్తుపెట్టుకోండి. బినా, సో బినా, BINA. So is equal to TC is equal to KC into theta. So what is the B value is 2 millisestesla, 2 into 10 to the power of minus 3. And what is the current here? 5 into 10 to the power of minus 6. Sorry, minus 3. And number of turns we have to calculate. And also area is 200 into 10 to the power of minus 6. All are 6 only. And the Kc value is 0.16 into 10 to the power minus 6. And the theta value is 90 degrees. I can say that it is pi by 2. Theta value is pi by 2. Okay. So convert into radians. 10 to the power of 6, 10 to the power of 6 is cancelled. All are minus, see, 2 into 10, 2 in 5 is 10. So here it is 10 here. And these two zeros means 1000. 10 to the power of 3, 1 is gone. And these two are also gone. These two are also gone. 2 into 5 is gone. And these two zeros is also gone. 0.16, so 0.04 into 5. So here 0.4 into 3.14. I think it is 4 4 is 16, 4 1 is 5. So 4 3 is 12. 126 or 136? Tell me. 126. Yes. Excellent. 126 is the correct answer. 126 is the correct answer. Yes. Try to solve this. It's theoretical questions. Yeah. No one gives the response. Consider the following statements with regard to thermoelectric ammeters. See, thermoelectric ammeters. Yes, tell me. If the frequencies varies, RMS value is also varies. No? If the frequencies varies, RMS values is also varies. No one is giving reply. Why? Yes, no one is giving reply. Why? Thermoelectric instruments. Yes, fast response. Tell me. No, no response. Why? Shall I take the rest? No response. Okay. See, as the frequency varies, RMS value is also varies. RMS value is also root mean square value. They are severely affected by stray magnetic effects because weak magnetic field is present. Okay, they are primarily designed for current measurements at high frequencies. Okay, they have low sensitivity. Which of these are correct? So they are primarily designed for not for the high frequencies. Okay, normal frequency it means measures, high frequencies also which measures. So I think it is 2 and 4. So 2 and 4. So 2 and 4 is A option is correct. Yes, A option is correct. Yes. Try to solve this. Current in a circuit is measured using a potentiometer. The voltage drop across a standard resistance 0.1 ohms and balanced at 1.018 volts. 1.018 volts is balanced at 50 centimeters. The current in the circuit is asking. Okay, so which is related to potentiometer. This question is related to potentiometer. See here as such. So what I covered today, so except the measurement of power, yes, we'll discuss measurement of power. So fundamentals we covered. Okay. So if you join in this Europedia, it will be helpful for you. Okay. So we will discuss in detail. Yes. No reply. No. No response. No response. It's a PSSPDCL 18 question. Think. So here the voltage drop across a standard resistance point on ohms is balanced at 60 centimeters. Okay. A standard cell of EMF of 1.0 balanced at 50 centimeters. Okay. Right. So 1.018. This is called the 1.018. 1.018 by 60 into 50. Standard resistance he is having 60 centimeters wide. 60 centimeters wide. Slide wire. So here, first of all, you will take a galvanometer. I am not trying exactly. So standard resistance of 0.1 ohms. So this is called the 0.1 ohms and balanced at 60 centimeters. A standard cell 1.018 volts. 1.018 volt. It is balanced at 50 centimeters. Now what is the current is asking? Working current. So working current is asking. So here it is the voltage is there. The resistance is also there. So you should yes, no one is giving reply in a potentiometer. Okay. See, check once, check. Yes, C. Okay, 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 okay. All of you telling that C. Yes, yes, everyone got the C. Okay. Yes, so C is correct. C is correct. Okay. Where VR is equal to 1.018 into 50 by 60. Sorry, 60 by 50. So I need 50. Okay, this is 1.2216. IR is equal to V by R. So 1.2216 by R. R is how much? 0.1. The C option is correct. The C option is correct. So 48th question. 48th question. So try to solve this. A PMMC meter has an internal resistance of 200 ohms and the current required for its full scale deflection is 50 microamperes. The meter is capable of measuring on its own a maximum voltage of. Yes, sir. D. Someone is answered. No. Why is current shock decreasing? Okay. So D. PMMC instrument. Yes, PMMC instrument has an internal resistance. RM is equal to 200 ohms and the current required IM is 50 microamperes. 50 microamperes. The meter IM into RM 200 into 50 into 10 to the power of minus 6. So that is 10 into 10 to the power of minus 3. Oh, all of you got already. D. Yes, small D option is correct. So D option is correct. This is a procedure you have to remember. Right. So one thing, if you join in your PDF, so you will get number of solutions. I will give the assurance that if you solve the papers or objective questions, not only previous of AP Genco or AP Transco or what or PSUS, if you solve IES questions and GATE, so maybe you should not mug up all those things. You should not mug up and try to know the concept through question. Okay, right? So one more problem we'll discuss. Now it is related to. Now it is related to. Right, measurement of power. Right. In 2 wattmeter method, wattmeter method of 3-phase power measurements, when the power factor is 0.5, this is very much important on this concept. Okay, so first of all, W1 is equal to W2, and the B option is W1 is equal to minus W2, and the C option is only 1 wattmeter, and which is not equal, and also which is not equal and not positive. Anyone try to solve this problem? C is only one power. Okay, what is the formula of this one? So W1 is equal to V1 I1 cos of 30 minus 5, and W2 is equal to V1 I1 cos of 30 plus 5. Yes, everyone is answered. Tell me, A, is it equal? Let's check it. Is it equal, or someone is answered C? C is correct answer. What is the power factor value? Power factor is 0.5, and the power factor angle is 60 degrees. The power factor is 0.5. Power factor angle is 60 degrees. So substitute here. So cos of 30 minus 60, 1 power, W1 is directly proportional to, so cos 30, yes, cos 30. But what happened to the W2 is directly proportional to, so V1 I1, I am not writing V1 I1. So cos of 30 plus 5, 30 plus 60, cos 90 value is 0. Yes, W1 is the correct answer. Only 1 wattmeter. Sir, this formula maybe you can use it as 30 plus 5, and if it is 30 plus 5, it is W2 is 30 minus 5. Okay, so it is not a fixed. You can use any wattmeter, but it is clearly given that in that option is given that, so reading is only 1 wattmeter, measurement of power. Okay, and also in the measurement of power, so this is called the wattmeter, right? So MLCV. This is our wattmeter. Wattmeter is our wattmeter. Okay. Now what ML represents? What CV represents? Which coil? We are having a current coil and a pressure coil. CC and PC, yes, someone is answered already. Yes, this is called the CC and this one is called the PC. Yes, in this, which one is fixed coil? Which one is called moving coil? My question is, which one is fixed coil? Which one is moving coil? CC is fixed coil. Okay, fixed coil. This is very important. This is very much important. Okay, right? Okay, ma? Right? So, is this session is useful for you? At least one like or comment, so that I will be very happy. Right? So all we discussed, so almost all problems from 2010 to 2020 questions. Okay. So we discussed almost 50 questions in electrical measurement subject. So just we are touching the measurement of power and measurement of energy, measurement of resistance, inductance, and capacitance, and transducers. We are having transducers. Okay. Thank you, ma. So good night and all the best for your exam. Every live, I will tell you all the best only. Okay. So when I say all the best means definitely you will score and you will get job. Okay. Thank you. Good night. Okay. More bits, definitely, definitely, definitely. See, 2 hours. We are enjoying it. Okay. Thank you. Thank you. Thank you, ma. Okay. End stream.